Okay, so let's go a little bit deeper into the TFT cell. What we have inside, we have this part that is like well known for us from the monochrome display. Welcome at Riverdi University. My name is Kamil and I'm CEO and founder of Riverdi. In this session, we will talk about the most important displays from Riverdi point of view, that are TFT displays. So full color displays. We will talk about their basics. First, we will review and refresh our knowledge about the TN and LCD displays in general. Later, we will talk about the TFTs, how they differ from regular monochrome displays. We'll talk about ghosting effect. So we'll talk not only the technology of a TFT, how it's built, but also about some phenomena like ghosting effect or grayscale inversion that are very important when you use a display. Yes? So they are important to understand. Then we will talk about different technologies of a TFTs, so like TN, IPS, VA, and of course we will talk also about transmissive and transflective displays, because the TFTs, they also can be transmissive and they can also be transflective. Not the last part, we'll talk about the backlights. Okay, so let's start with the some like memory refresh about the most basic liquid crystal cell, which is a twisted nematic kind of display. So in this part we see that the light can be transmit through the cell or blocked by the liquid crystal cell using the voltage. If you want to learn more about the monochrome displays and the basics of LCD displays, please see the link in the right corner or down below in the description. There is another video that goes a little bit deeper into that. But here we just want to remember that we talk about the LCD TFT displays, and we need LCD cell, which is like, you know, blocking and transmitting the light using the voltage. Okay, so what is a TFT display and how it's different from monochrome display? So first of all, TFT display, we call it active display. Active means we have a transistor or more than one transistor in every cell, in every pixel, and actually in every subpixel. So a TFT is abbreviation from a thin film transistor. So transistors that are very small and very thin, and they are literally built into the pixel. So they are not outside somewhere there in a controller, but they are in the pixel itself. So for example, this big TFT 55-inch display contains millions of transistors in the pixels. We don't see them because they are very small and they are hidden, but in every corner we see them. And if we zoom this display very close with the, we'll go closer, then we will see something like that, yes? So here in this image we see subpixels that are basic colors, so RGB, and then we see also this black part that is uncovered here. This part are the transistors and some electronic circuit. I will show you a little bit more what is inside there on the next slide, but here we just need to know that we have the pixels, we have a subpixels, in every subpixel we have a transistors, and this make the display active, this make the TFT display. Of course, the TFT display usually is a color display, not necessary. There are monochrome TFT displays, so the displays that are active have the transistors but have no colors, and the colors in a TFT normally is added by the color filters, yes? So we build pixels, the very small pixels that we call subpixels, and every one of them we cover with different color. As I said, usually it's RGB, so red, green and blue filters. but we also have a displays that are like RGBW, will be, you know, red, green, blue, and white. Of course, for white we don't need any filter, so it's like just naked pixel to make the display brighter when we have the white screen. Actually, this display that we have here is RGBW type, but here we have only RGB. And what is interesting is that the white part of the screen, despite this one being RGBW, if it will be the regular RGB display, will look exactly like that when we go closer. So if you will go far away from the screen, this part will become white for you. That is how the lights are being mixed together and generate the white light. Yes, so if we go close to the screen, we will not see white light at all. We only see it from the distance. Okay, so let's go a little bit deeper into the TFT cell. What we have inside, we have this part that is like well known for us from the monochrome display. So we have a cell, we have liquid crystal, and of course we have polarizers and ITO layer for the electrodes. But additionally here we have a electronic circuit. Yes, usually it's a one transistor or more, some capacitors to sustain the pixel state when we switch off and on the pixel. So in a TFT display, the pixels are way more complicated, because we don't need to only build a liquid crystal part, but we also need to build an electronic part. That's why the TFT display technologies are very expensive to manufacture. Okay, so here is the real, let's say, cell inside, and here is the circuit. So if you are familiar with the electronics, you know that the transistor is like kind of a switch. So this transistor allows us to switch on and off the pixel. And because it's built into the pixel itself, it can be done very fast and controlled, very well controlled. Yes. So we know exactly, we can control exact state of every pixel, and actually not only the states that are on and off, full on and off, but also all the states in between. So in a TFT we use it a lot. We use a lot of grayscale. Yes, so we like switch on and off the light with some steps, and usually for TFT it will be 8 bits per color. So we have 256 steps for every color of the brightness for every subpixel, and then because we have three subpixels, then we have 24 bits. Yes, if we have 24 bits, 2 power 24 will give us over 16 million bits, 16 million combinations, 16 million colors that we can at least theoretically show on our screen. That's why from RGB pixels, from 3 basic colors, we can build 16 million different colors, from white to black and all the way. Okay, so once we have a display working, from our perspective, it's not only important to show the screen, but also in this in our university we learn practical things, and one of it is LCD TFT ghosting. Yes, so we know how to create the image, but what is happening when we have the image on the screen for a long time, for example, and how to prevent it. So we have something called LCD ghosting. We don't see it very often, but in some displays this phenomenon still exists, and it really depends on many conditions like temperature and even the screen image that we mostly put on the screen. So there are some techniques when you build your application to avoid, like here, very rapid contrast change, and of course to avoid the positioning the same image in the same position for a long time. For example, this logo here, if it always be here like for 1 year or something, the crystals will become, they will memorize, let's say, the state, and later when we change the screen, we may see some ghosting on the back of this screen. Maybe you have seen this already, maybe not, but this phenomenon is a common for pretty much every display technology. As I said, it's not very visible, but it is. So even the companies like Apple, they put the note on their website. You can find it probably easily, how the IPS technology work, and that as a user you may expect this kind of phenomena. After some time it's called image ghosting or image persistence. They even have some app, I think, to like remove it. That means to keep, for example, the white screen for long, to reset the pixels to the regular state. So even the Retina display can have this phenomena. Yeah, here we have some Apple steps. From them, what we can do to fix the image persistence. As I said, you can probably easily Google this. Basically, everything is around to make the displays in a like factory state. So to keep, for example, one screen for a long time, usually it's a white state of the screen. Okay, so another very important feature, I would say, or the bug of a TFT displays, especially TN LCD displays, is a grayscale inversion. So the phenomena that is changing the colors of the screen quite sudden when we change the viewing angle, and it's only from one side. Yes, so usually when we buy a TFT display, we need to check first what kind of technology we have. If it's IPS display like Riverdi IPS display line, then we don't need to care about it, because all the viewing angles will be the same and all of them will be very high, like up to 80, 85, 89 degrees. So this phenomena is not there. But if we buy the more common or like older display technology, that will be a TN, so twisted pneumatic display, we need to think where we will use a display, because we'll have this problem with the grayscale inversion, and one viewing angle will not be good, for example, for humans to see, let's say. Yes, so this is sometimes confusing. I will show you this on the next slide, because most of the factories, they defined something like viewing direction of the screen, and you need to be careful, because some of the companies, they mistake this for grayscale inversion side. So I will go to the next slide, where we will see a little bit more explanation about the grayscale inversion. So like Wikipedia, because this is from Wikipedia, from IPS description type, you will find the link down below in the description. So it says that some early panels, actually it's not early panels only, even nowadays you can buy a TN display, they are very popular. They will have the grayscale inversion, not necessarily from up to down, it's for like a monitor, but of course it can be any angle. You need to check in a data sheet. Yes, that's why the technologies like IPS, so in-plane switching, that we are using in the latest displays from Riverdi were developed, or VA, to avoid this phenomena. Yes, and explanation on Wikipedia, funny thing, comes from the Riverdi explanation. So if you will go to the IPS and will want to learn about the what is the grayscale inversion, you will find the text from Riverdi website. So the twisted pneumatic display suffers from phenomena called grayscale inversion. It means the display has one viewing side where the image colors suddenly change. Yes, so this is what we already said. Okay, so as I said, it is tricky and you need to be very careful. So what I'm showing here is a part of the LCD TFT specification. and it's a specification of a TN display, yes? So twisted nematic display that has a problem, let's say problem or phenomena called grayscale inversion. And if we'll go to this table, optical table, we will see the viewing angles. They are defined to be 70, 70, 60, and 70 degrees. So that means the maximum viewing angle that the user can see. So normally we may think that the 70 is better. So we will choose, you know, the, let's say, left and right side to be 70 degrees and then up and down. And if we will not know about the grayscale inversion phenomena, we may put our user on the bottom side, yes? So let's say this will be like 6 o'clock display, could be from this specification only, because of course we want to have the viewing angle as wide as possible, yes? So we always choose the widest viewing angle. But you need to be careful, and here we see that this top theta viewing angle is here and is of course on a 12 o'clock direction because it's a top viewing angle, and actually it's lower than the rest. And if we see the specification, this one is a correct one, we will see that this display was defined as a 12 o'clock display, yes? So we see that this display is the best to be seen from 12 o'clock. If we'll go deeper, we will see that at 12 o'clock has the lower viewing angle, 60 degrees, yes? What does it mean? It means that on this side, there will be no grayscale inversion. So if we will go to 40, 50, 60 degrees, and even a little more probably, we will still see the proper image, maybe with lower contrast, but the colors will not change. If we will go from the bottom side, so that will be the 6 o'clock, where we have the grayscale inversion, we will see this after, you know, 70 degrees or lower, we will see sudden color change. And of course, this is something we want to avoid, yes? So when you buy the older technology TN display, which are very popular still, and Riverdi is selling them as well still, you need to be careful where you will put your display, yes? Because if it will be like a handheld device, you will see this display from the bottom, yes? But if you will put it on the wall, you will see normally the display from top. So you need to define it during the design, because later to change this direction is usually impossible or expensive. So please be careful with the viewing angle of the TN displays. Okay, so now we will jump a little bit into the older TFT technologies that allow us to have wider viewing angles and also like more vivid colors. So as I said, the most basic technology for monochrome, but also for TFT, is a twisted nematic TN displays. And this kind of display, as we already know, have a problem with the grayscale inversion. So on one side we have a higher retardation, and we let's say we will not see the image clear. So that's why we have other technologies like VA, which is a vertical alignment technology, where we put the liquid crystal in different organization, and IPS, which is in plane switching, another variation of the TFT technology. And as you see, the VA and IPS, they don't have a problem with the viewing angles. You can see the image clear from all the sides, yes? So it doesn't change the image for you. And I can tell you that all of TV nowadays, they are IPS or VA, all the tablets, all the, of course, mobile phones, because you can turn them around and see the image clear from all the sides. But TN technology is still widely used for a monitor application, because monitor usually is in front of you, and most of the time you look on it straight, or you look it from up or left or right side, but you very rare look on the monitor from the bottom side, yes? So on the bottom side in a TN monitor, we can place the grayscale inversion viewing angle, and this still is very practical to do because we don't look on the monitor from this side, yes? So this technology can be cheap, but also have some advantages for the gamers, because it's very fast technology, yes? So you can still use it, and it's still popular. And beside the liquid crystal inside, different organization of the liquid crystal in a VA and IPS, we also organize the subpixels a little bit different. So when we look on the TN, the simplest TN display, we will just see the subpixels, yes, with the color filters that we talked already about that. But if we would see the VA or IPS displays, most displays, they will have like subpixels of the subpixels, yes, so it's even more complicated. And then we have the subpixels divided into the smaller parts where we put different organizations of the liquid crystals inside. And in this way we can achieve even wider viewing angles and even better colors for the user, but of course it's more complicated and more expensive to do. Okay, so short summary of the IPS and a TN display or IPS or VA technologies. So you can see here on the small image, and we have the TN display here, and you see the grayscale inversion. So when you are moving as a viewer of different angles, the image is not very clear anymore, yes, to in basic words. But for IPS or VA technology, the effect will be the same. From all the sides we see image very well, yes. So these are technologies that are popular where we need wide viewing angles, and TN is popular where we don't need, as I mentioned already, for example in monitors. So here we have few advantages of IPS. So they are very accurate with the colors, and of course we have the wide viewing angles. What is also important and practical in our projects is that the IPS is less sustainable to the mechanical force, yes, on the screen. And when we put the mechanical force on the screen, when we have a touch screen optically bonded, yes, so when we touch the touch screen, we push actually the display as well, and we squeeze the cells with this mechanical force. And when we have a TN display, every squeeze of the cell changes the image suddenly. With the IPS, because we have in-plane switching different crystals organization, this effect is lower, yes. It's not completely removed, but it's way lower. That's why IPS are very popular for smartphones, tablets, etc. when we have the touchscreens usually optically bonded. Disadvantages, I put the question mark here because some of them are true, some of them not. It really depends on the real case, yes. What kind of display, what kind of IPS technology is there? So sometimes they can be more power consumption, in many cases not. They can be more expensive, but not necessarily need to be. So the new IPS panels can cost similar to TN panels, but for sure IPS panels basically have a longer response time, but again, it's not the rule. You can make IPS panels that are very fast and even faster than TN panels, but if you want the fastest possible display, probably the TN panel will be the fastest. That's why I mentioned before that the TN technology is still popular in the gaming market. Because usually we are in front of our monitor straight, so we don't care about viewing angles that much, but we care how fast the display is. Yes, so the TN can be very fast, and of course you can find a lot about this in the internet, a lot of discussions, which technology is better. It really depends what you want to achieve. Okay, so now we will jump into the backlight types. So what we see here, we have 4 different types of the backlight possible. So the most common, and I would say 95% or 90 maybe 9% of the TFT displays that we have on the market, they are just transmissive displays. Yes, so we need the backlight from the back, then we have the LCD. Here it will be LCD TFT, of course, layer, and we have a screen surface and the viewer. So for transmissive, if you remember from our monochrome session, you need the backlight to be always on. If you will switch off the backlight, you will not see anything. Yes, but same as in monochrome displays, less popular for TFT displays, we have transflective displays. They are not popular because usually when you have a transflective TFT displays, the colors are very weak, so they are not bright. The display it's not very practical to use. Yes, maybe you can see the screen, but it's the application is limited. Some transflective displays are used by military applications where you care a lot about the power consumption, so you switch off the backlight and maybe you agree to have the lower quality of the image, but you can still see the image. Yes, so the power consumption saving is the most important in some kind of application, and you can use the transflective display. Reflective display almost never used in a TFT, but there is one technology I will show you later that is called low power refractive display. Is used in a TFT, but it's not very popular, and it's kind of new technology, I would say. And of course we have reflective displays as a variation with the front light. Yes, so we can add the front light for the reflective display and have the image even without external light. But as I said, 99% probably TFTs are here and the rest is there, so they are way lower in numbers on the market. Okay, so here we have the display that is called LPRD, so low power refractive display. So this kind of display use the environment light, ambient light to reflect and still can produce some colors. Of course, as I mentioned, the colors are not perfect, they are not perfectly clear, but this technology is getting more and more popular because it allows to have a color display in a battery powered applications. Yes, so for example, a watch would be use case for that, or maybe electrical bike or like a scooter, electrical scooter, of course, and where we can have some image and not only boring monochrome display, but the color display without the backlight, so we can see this image even in a strong sunlight environment, and we don't need the backlight at all. So this kind of technologies are getting more and more popular